Welcome back for our second video. All I am going to do in this video is show you the proof, the derivation of the quadratic formula. But I will sing songs at the end, so if you just want to fast forward for the songs, that's fine. This is actually one of the few skippable videos, but I do actually like, in class, I would literally just show you the slide and be like, look, it's provable, done. But since I can, I'm actually going to go through it. So the idea is, since we're doing completing the square, if I take a generic ABC quadratic and go through my entire completing the square process, which I'm going to do on the right with this ugly odd square, then at the end, you're going to see the quadratic formula on the left, and you're going to see the answer that we've been getting from all of the completing the squares we just did. So this is literally like how formulas can be derived, actually. All right, so the first step, we have a 3. We don't want to see the 3. So the first thing we do is divide everything by 3, which in the proof, we don't know what our a number is in the generic form, so we divide everything by a. But now our x squared does just have a 1, and we have the very disgusting 5/3 plus 1/3 equals 0. So here we have b over a plus c over a equals 0 over a. And then the next step, we want to move the constant over. So we will have x squared plus 5/3 x equals negative 1/3. Now, I'm going to write it a little bit differently than they do, because the way I've been doing it, I skip to the factored form, and then I go back and write in this middle line. It's just kind of the way my brain processes it, because if I'm going to figure out what the half number is, I may as well write it where it's going to be. So my half number, half of 5/3, is the same as 1/2 times 5/3. So 1/2 times 5/3 is 1 times 5, 2 times 3 is 6. So the number we are going to see here is 5/6. And we still have our ugly negative 1/3. And now the number that we would add to both sides, I'm going to go back and make it look like this. So we still have our x squared plus 5/3 x plus half of 5/3, 5/6 squared. Which would be 25 over 36. Actually, I'm going to erase that 1/3 I put there. Minus 1/3. I'm actually going to combine these. The quadratic formula, it will sort of combine them in a second, but it'll look a little funny. Oh no, they're actually like right away. So what it's missing is to get the 4a squared that we end up here, the c to have that common denominator is missing a 4a, so that's where we end up with 4ac. So for ours, I will just go ahead and write those two. So the 25 over 36 minus 1/3. So we're just going to keep copying the left side. Sorry, I touched the touchpad. How dare I? So we still have our squared form. Still have the 25 over 36. But now the number I'm missing here is 3 times 12 would get me to 36. So it's 12. But I want to multiply the bottom by. Thus, I also multiply the top by 12. 4 times our original a number was 3. So, makes sense with what we're seeing on the left side. All right, so still x plus 5/6. But now I can actually minus 25 minus 12 is 13. And now it's 13 over the lovely 36. Okay, so now we are at this stage. And then look at the next step. They put that square root in. Oh my God. But that's where we're at. Not so crazy looking with the numbers. But the quadratic we have as an example is the like absolute worst it can get for completing the square. But this is just to show you how the quadratic formula gives you the exact same answer because it's just doing the same process and just shortcutting it for you. So we put in our square root. So this left side is now just x plus 5/6 equals plus or minus. Actually, I'm going to go ahead and split the root just to kind of show you where it's heading. So I can split the square root across division. The plus or minus stays with the top guy. It can stay with the bottom guy, but only with one of them. You don't do it on both. That gets very confusing. So we usually leave it with the one that's going to still have a radical if there's a radical. The bottom is actually always going to work out to a perfect square. So our denominator in this case, square root of 36 is 6. Oh, look, that's actually what we had over here. That always happens. It's the nature of the process. So we have 5/6 equals, and now this is plus or minus the square root of 13 over 6. And see, that's there. I've taken the square out. I've got the plus or minus just on top, and therefore a squared, square root of 4 would be 2. Square root of a squared is just going to be a. And then we're going to move the 5/6 over. We're going to minus 5/6, minus 5/6. And now I want you to notice they're both 6, so I'm just going to write it all as one fraction, which is where we get our answer. Again, I touched the touchpad. $13 is prime, so it doesn't reduce at all. So that is the solution. X is by itself, which is how we solve what we want to see. X equals some number. And over here, we have the standard looking quadratic formula. There's where it comes from. So down here, we have our pretty formula. And then I've sung this two ways. One is Pop Goes the Weasel tune. The other is Row, Row, Row Your Boat tune. So for Pop Goes the Weasel, x equals negative b plus or minus the root of b squared minus 4ac all over 2a. So now you're going to hear me kind of hum when I'm doing a quadratic formula. At the end, I'm like, That was Row, Row, Row Your Boat. Wow, I'm drawing a blank on Pop Goes the... So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the one I have. So when I get to the end of a quadratic formula, I'm like, when I'm writing the big fraction bar in the 2a. So there is our quadratic formula. You must have A, B, and C with a 0 there. If it is not a 0, you can't use the quadratic formula. Then if you have that format, then you can substitute A, B, and C into this formula and just simplify the numbers, crunch the numbers, answer for X. Now upcoming, some of your ALEKS work is going to ask you to write the decimal answer. Others are going to ask you to write the exact answers. Exact actually means don't write the decimal. They want you to leave square roots as square roots. Like the square root of 2 is a very particular number. And it is not the same as one of the decimal approximations. Like it's 1.414, but it keeps going. But if you just stop at 1.41, that's not the same as the square root of 2. It's actually a little too small. And any decimal approximation is going to do that. So when mathematicians say exact, they mean as a square root. In any sort of science class, They don't want the square root. They actually want you to use a couple of the decimals, do the calculation, and then figure out your significant figures. All right, so I'm going to pause it here, and then when I come back the next video, we're going to use the quadratic formula to solve, I believe, 5 quadratic formula ones. And this is where, even though they're ugly, like, this will take care of all the ugliness for us. It's lovely.